Hello everyone, I'm Pierre Palatin and I've been an SRE in Switzerland at Google for the last 15 years. And today I want to talk about how we've solved turnups at Google using Prodspec Annealing. So Prodspec Annealing is a pair of tools that I've created with many other people. And that's Google internal solution for continuous deployment. Now I specifically mean continuous deployment, right? Continuous integration is a different topic that I'm not going to cover today. So here we're taking over from an artifact typically created by one of our build systems. So those projects, Prodspec Annealing, have been started back in 2015 in one corner of Gmail. Gmail is a very large system, and in one corner, we were having a lot of problems with deployment, and we wanted something else, something better. And we didn't went with a grand architecture. Instead, we just wanted to try to do deployment differently using continuous intent-based deployment. And well, it really worked out in the end because today, most of Google is relying on Prodspec and Annealing somewhere in their stack at the very least. And so along this journey, of course, we've learned several things. And that's what I want to talk about today, like 3 decisions, 3 principles that really worked out, that stood the test of time. And I would love to talk about more technical details also. There is no time for that. However, there is a Usenix article which covers many details about Prodspec Annealing. Okay, so I've mentioned we started in 2015 and we wanted to change something about our deployment. But what was the issue? Well, we had 3 main issues. The first issue was the amount of infrastructure we had. For even running a simple service, we had and we still have tens or hundreds of aspects to configure, and that was not scaling. And that's probably something that many people are also familiar with, no matter what you're running. The second problem was the amount of configurations. In configuration, there was tons of different configuration files, different configuration format. It was very difficult to find what was where. And the third problem was the deployment part. Once someone actually managed to change their configuration, they were always wondering, okay, what do I do now? Do I just need to wait because there is something automated? Or is there an obscure command line tool to actually run? Or do I need to click on a UI? Anyway, we were struggling with those problems. I suspect those are very common problems. And so to tackle that, we decided to change a bit of approach to continuous deployment and using continuous intent-based deployment. 4 years of term before, I'm going to break that down very quickly, what each term means. So the first term, continuous. So here it means that we want that when someone has modified the configuration somewhere, that it gets propagated to production automatically. In most cases, there should be no other intervention besides doing the initial change that person wanted to do. Intent-based. Intent-based means that we want to describe the target state of production and not how to get there. Meaning that if you want to resize a job, you have 3 replicas of these jobs. Currently, you want to move to 7. Well, what we want to be able to do is to indicate in the intent that it's target of 7. We do not want to say something somewhere which says, oh, please add 3 replica. No, we want to indicate the end state. And the deployment, well, that's what we want to do, right? We want in the end to be able to configure a production so we can actually run products on them and actually serve our users. And we want to do that safely, typically. So, and that's how we ended up with Prodspec Annealing. And Prodspec Annealing, so is this intent-based system. And it has mostly 3 large parts, 3 large layers. And I believe that if you have a system which is vaguely also intent-shaped for your deployment, those 3 layers are also going to be present in your own system. They might be implicit, while some of our layers are more explicit, but it's going to be there. So the first part is the starting point. That's what we call the sources of truth. That's what you usually think as configuration. Typically, that's a bunch of configuration files. Sometimes there are also databases there. That's what you modify when you want to actually change something in your production. For example, you have a new version of your binary. You're going to edit a configuration file, which was made for that. That's the sources of truth layer. That's the starting point. Then we have this notion of intent. Now, for many people, the intent, the difference between the intent and the sources of truth is going to be very implicit. But the intent is the representation of what production should look like. And for us, it's a very explicit step. I will talk about that a bit more later. And then there is a system which takes the intent and makes sure that production actually looks like it. That's what we want to do here, right? In our case, that's something called annealing, but those almost always exist. If you think about the kube control applied in the context of Kubernetes that you're running, it's the same, that's this layer, that is the same thing. In your case, that's called annealing, that's a very large and complex system, but in spirit, they are the same thing. So as I mentioned, I cannot dig into the technical details about Prodspec Annealing here. I'm going to just mention the principle that really worked for us, like decisions that really turned out to be the right one. This project started 8 years ago now, and with just a handful of service, and we grew. Yes, we had probably a few internal outages because of it. I think we're in a much better place now for reliability. Automation does help reliability. It does also introduce a few failure mode, new and exciting failure mode, but overall that's an improvement to reliability. And now, if you used almost any Google product system, Prodspec Annealing are probably involved in their deployment. Okay, so what are those principles that actually made Prodspec Annealing successful? So the first one I want to mention is using a consistent intent format and not a mix of configuration files. We still have this configuration file, but we also have an explicit intent, which has this like very common structure across everything. So we're using Protobuf because we are Google, and so we use a Protobuf for everything. But that does not matter, that part, right? The important is that it's structured in a common way. And it, of course, something like the configuration of a switch, of a network switch, is not going to be the same as the configuration of your JavaScript frontend. But still, it's all added up together in this one structure. If you're familiar with Kubernetes and custom resources, specifically in Kubernetes, that is very much the same principle. So why is it important? So there are plenty of reasons why it's important. But I think what is very interesting there is that it makes it easy to look at the intent. And it turns out there are many things which are interested in looking at the intent, like command line tool, things to produce reports, monitoring, dashboard, reporting, whatever. There are plenty of things which are interested in looking at the intent. And when your intent is just implicit in the middle of tons of different configuration files in different formats, those tools will have a very hard time existing. And sometimes you will just not even do the tool. So maybe you will not do an analysis which would have helped the project or a postmortem down the line. But here, because we have the intent there, which has this common format, we can very easily look it up. And that's also true on the infrastructure side, so what we're trying to update here. Because the infrastructure do not have to care about the various configuration or how people are actually configuring their services. They just need to care about the intent. For example, our cluster management system called Borg used to have two fairly complex configuration languages, and tooling was integrating with one or the other. And it means that if your service was using one of those configuration languages, it was impossible to use half of the tool of the company, which was obviously a very bad situation. If we take a step back, fundamentally, it means with an explicit intent, we're moving from a n times m problem to a n plus m problem, meaning that instead of having to integrate plenty of parts, pieces of infrastructure with plenty of configuration format, we move to a place where we need to integrate the configuration format to the intent and the infrastructure with the intent. So we get rid of the combinatorial explosion of sorts that we had before. That part worked very well. The intent now is used everywhere for everything. The one difficulty I would imagine here is that you need to have very good control over your ecosystem to be able to do that fully, which is our case. And I can imagine that if you're using more off-the-shelf tooling and so on, it might be a bit more difficult. Now, it's great to have this intent. When you have it, it's going to work very nicely, but how do you maintain it? It's impossible to edit it and to maintain it manually. That's just not possible at almost any scale, I would say. And here, I believe that it's very important that this intent is explicitly generated. There are still the sources of truth, but now we take the sources of truth, and there is an explicit generation pipeline which does generate the intent. Now, I believe that everyone does that already. If you have any kind of production system, you probably have a templating language somewhere, which is the same principle. And maybe you have some shell script, some Python script somewhere, which generates some YAML. And, well, that's the principle of this generation pipeline. And our approach there was to think, okay, that's going to happen. Our users are going to generate the configuration anyway, going to generate the intent. So we made that a first-class citizen. It's a core part of our design to have this generation pipeline, which means we can build on it then. Again, there are plenty of advantages of doing that. I think the most interesting part is that it allows to tailor the inputs and the outputs to the consumer. So for the sources of truth, that means we can optimize the sources of truth that needs to be updated by humans. We can optimize them for that. So no more problem of, oh yes, this value, when you update it, please think about updating it here and here. No, you just have it in one place. And on the other hand, on the consuming side of the intent, that's the same effect, in the sense that something looking up the intent does not have to guess how the service is organized. They can just look, okay, I'm looking at the intent, I'm looking at the resource I'm interested in, and the data is right here. Which does mean we have a lot of redundancy in the intent, but it's good, it's fine, because it's generated. For example, we like knowing about the geographical location of resources. So where is a resource in the world? And that information is tricky to get right and has a lot of variation depending on services. A simple service, internal service running in only one location, well, the geographical location is kind of obvious, right? It's where it's running. But then we have very large services which have remote coverage and other complicated things, which makes it non-trivial. And here we just encode that in the generation pipeline. It means that something which is interested in knowing where a given resource is can just look up this resource, and it's been duplicated where it needed to be duplicated, and the consumer can just be dumb and just look at the data. So the difficulty here is the amount of data, interestingly. That's one thing we're struggling with. We are generating a lot of data, and the latency we have to generate the data is much higher than what we would like. I don't think that's a fundamental problem with this approach. I think it's just internal historical artifact as things go. However, one thing to keep in mind is that people are always surprised time and time again of how much configuration a service needs and how often does it changes. Like even people who are super familiar with our service, they get surprised by that. Okay, so we have our intent. It's great. We want it in production now. And we want to do that continuously. Turns out workflows don't really work for that. And the pattern we kept coming back to again and again is this pattern of select, update, validate. So what does that mean? Well, there are 3 steps, and the name. The first step, select, is probably the most important one. Here, we look at the list of resources, and first, we filter the resource that needs to actually be updated in production. So those where the intent is different from the state of production. And amongst those resources, we pick only those which are ready to be pushed right now to production. For example, you have a new version of your binary for a job which is running in multiple clusters. Well, the first time you want probably to only push a single cluster to canary it in one place, right? And that's exactly what select is going to do. Select is where this logic is encoded. It's going to say, yeah, that's the first time I see this binary. Let me ping only a single cluster and maybe even a smaller one to reduce the risk. So once you've selected which resource needs to be updated, well, the update actually happens. So here's that doing whatever needs to be done. Contacting the load balancer, for example, to actually change its configuration, or pushing the new job to the cluster, and so on and so on. And then we reach the third type, that with modified production, it's always risky, right? And we don't want outages. And when there is a risk, we want to reduce it. And that's what Validate does, is that we've modified something, we verify that things are still working. For example, you've modified a database schema, well, you verify that the database is still working well. And maybe also check that the front end is also still working, because what you modify might still be working, but that might have destroyed everything else. I'm sure that everyone has post-mortem like that. And from there, well, there are two options. Either the validation did not pass, in which case, well, we stop everything, or maybe we even automatically roll back and probably alert. So generate some page to alert some humans, or everything is good, and then we start again. And then we select another set of resources and maybe 2 clusters to push this time, so we can go faster and faster. So why is that important for intent-based here? The thing is that workflows are great when you think in terms of changing a single resource. You look at the resource and you immediately know, you care about your resource, you know what is needed, your new job. Yes, I know I need to canary it there. Then I need to push it a bit further. Then I need to have some QA over there. Whatever. You know the steps. It's very intuitive. However, that works only when you think in terms of this single workflow. When you have hundreds of workflows working at the same time, then a very important question, and maybe the most important question, is how are they going to interact together? And when you're writing a workflow, it's super difficult to do so. With select, update, validate, there is a select step, which has this visibility across almost everything and can take the right decision at the right moment. It can react dynamically to what is happening. You're trying to pick a cluster to do this canary, right? Well, maybe you just realized that there was a new database schema which was pushed just before. You will probably want to hold off before doing any changes there. The main difficulty here is that workflows are a lot more intuitive to people. I mean, there is no way around that. People think in terms of workflow, think in terms of their resource they care about, and not in terms of select, update, validate. In practice, we found that with good UI, good tooling, and a bit of teaching, that can be overcome. So, that was 3 principles. There are, of course, many other important aspects in Prodspec Annealing. But here, what's really important, I think, is how it clicks together. Like, if you pick just one of those principles, you might have some benefit, not saying, but you will not get the real advantage of moving to continuous intent-based deployment. And because it clicks together, that gives you, those 3 principles gives you a control plane to our production, where you have good visibility into what is happening. And if you want to provide a platform to your users, for your user to manage their services, it's very important, because that's exactly where you're going to encode best practices and policies. For example, you want to forbid production pushes on weekends, but you still want to allow pushes of test resources. Well, that is possible. That's just a bit of logic in the select step. Same thing, you want the database schema version to always be more recent than the binary version. So what do you do in case of a rollback? Well, you need to be careful about that. But here, the select step, again, can determine that and hold off on whatever is needed and push the right thing at the right moment and guarantee this ordering. And it's not only the selection order, it's also on the modeling. For example, you do not want to allow your service owners to decide exactly where they're running. They are just saying, oh yeah, I want to run in 5 places, probably at least 1 in Europe, and so on, with this amount of latency. And then from there, you can have like centralized decision, if you want, to decide where it's actually going to run. Oh yeah, we have space here, we have resources there for running this service, and if we run it there, it's going to be less costly, and you can take those decisions centrally, because you have all of this visibility. So one of my favorite examples here is turnups. And I've mentioned that at the beginning, like this approach actually solved our problems with turnups. What we were doing before is that we were writing workflows instead, and that was never working. We had always the same failure mode with those turnups workflow, in the sense that when the workflow was used for real, so an actual turnup, then it was always broken. And so it means that the person managing the turnup had to both take care of the turnup and debugging a workflow, this using an obscure workflow engine typically. And it was ending up more costly than actually just doing things manually. But with Prodspec Annealing, we do not have this problem anymore. This problem basically disappeared. So why is so? Well, it turns out that managing a turnup, the really important part is the modeling of your system. You must have very good modeling of your system, of the service you're trying to turn up, to be able to turn it up, right? And with a workflow, it gets outdated because people change the infrastructure. Oh yeah, I've added a cache over there, I've changed this flag over there, and suddenly your workflow is not up to date anymore. But with Prodspec Annealing, with this continuous intent-based, because we're always exercising the modeling, then the modeling tends to be very much up to date. It's even more than that, because we are only using Prodspec Annealing to actually do any type of production changes. It's not that it's close to the right modeling, it's that by definition it's the right modeling. And it means that when we're doing a turnup, we just update a source of truth saying, please run my service in this extra location. And it just creates the right resources in the right place automatically. So yeah, that's it. That's the main principles that really worked for us for this continuous intent-based deployment system. For the technical details, there is this Usenix article which gives plenty of them, and of course, I'm super happy to talk about it. Thanks.